All right, good morning. What do you want to talk about? Do you have any questions? I actually don't have a whole lot to talk about today. So now's your chance to find out my special chai recipe or something like that. Any questions? Yes? What is my special chai recipe? Well, you can ask, but I'm not telling yet. You have to earn my trust before I share that secret. Any other questions? How are the labs going? You have if I poke my nose into the course shell here, we're in week 4. Well, there'll be a pretty good activity on Friday. Friday will be fun in class. Note that a week from Friday, Project 2 is due. So if you haven't been looking at all at Project 2, you may want to take a look at that. We can take a quick look now. So this one's a bit of a pain in that there aren't very many shortcuts you can take, and it requires a fair amount of code to do it. The labs, some of the labs actually have you write code that can be directly plugged into the project, so that is kind of nice, killing 2 birds with 1 stone there. So the easy part, the player enters 1, 2, 3, rock, paper, scissors. The computer randomly selects one of those itself. And the program then displays what the computer chose and what the player chose. And who won. I hope I'm all right not printing the rules to rock, paper, scissors. Ask the player if they'd like to play again. So it's in a loop and you do it over and over again. And so this is where it gets a little bit more involved, is since they can play multiple times, you have to basically keep track of 3 different things. The number of times that the player won, lost, and tied. And then you display those numbers once they say, no, I don't want to play again. You also have to keep track of whether they selected rock, paper, or scissors, or excuse me, the number of times for each of those. So right there you have 6 variables you have to keep track of. Wins, losses, ties, rock, scissors, paper, display all those. We've already talked about the rand function. And so that's all that information. If you do the extra credit, then you also have to keep track of who won the most rounds, whether it's the computer or the player. That's fairly doable, but what's a little bit trickier is you have to display the object the game winner won with the most. So it could be either the computer or the player who won the most, and whether it's the computer or the player, whether they won most with scissors or won most with paper, that kind of thing. And also what they should have chosen to win most of the time. So the extra credit definitely adds a layer of complexity. So there's that project. Again, before you hand in your final, or not hand in, but submit your final version of the project, be sure to click on the view rubric so you can read, and this is silly, so that you can go through there, know what you're being graded on. All right, so again, that's due a week from Friday. Any questions on that? Yes?
Does it only end when the user inputs capital N, or when they input anything but capital Y?
I guess I would follow the lab's behavior. I would check that rubric just to be sure, but my guess is the rubric isn't really being that nitpicky about it. And so, you know, really either way, whatever you go with is fine. Any other questions? Okay. How about the lab with the movie and the popcorn and the year? Anyone have any issues with that? Yeah.
So I couldn't like get it so the get line would work with the integer type. So I actually made the year a string and then casted it to an int later.
All right. So you used a little bit of more advanced voodoo there by reading it in as a string, casting it as an integer. How did you cast it as an integer?
STOI.
Oh, okay, it's good. That's a more recent function that came with the 2011 standards, so that's fine. But let's talk about that, and that's specifically why the lab was written that way, was for people to encounter that problem. And why the problem is occurring. So you need to solve the problem, but the most important thing I wanted people to come away with is why it was a problem in the first place. And this touches on, it actually is directly related to that video bits. The video bits talked about file input, and it talked about input streams generally. And I don't believe I did this in that video, but let me see if I can come up with a what do I want to do? All right. So let's look at this file in a way that we're not normally accustomed to seeing it. There's a utility called octldump. Let me see, I thought there was a, I think hex dump will give me what I want, but all right. So you can ignore these numbers on the left. That's just indexing the number of bytes into the file. The first character is a space, second character is a space, a space, a space, spaces. Well, darn it, hang on, I didn't want all spaces. I see what I did. Let's try that again. Yeah, okay. Space is space, horizontal tab, which is just the tab character. Space, space, this space, is space, a space, blah, 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 da, 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 da. Let me find something different. SE period, that's the end of the sentence. Then there's a new line. Then there's another new line. Let me bring it up here. So the end of the sentence is the period. And then there's two new lines. So one new line takes me there. A second one takes me here. And then there are two spaces. And then 324. Then there are two more new lines. A new line there and a new line here. And then I am happy. And then the file ends with another new line. So from the perspective of reading in the file, and this goes for reading in from CN from the keyboard, the program is looking at your input as what I have in the top frame up here, which is just a stream of characters, okay? And we get, as humans, we get hung up that these are, I don't know, 3, 4, 5 different lines, 3 different lines of text. Some are indented and there's a blank line here and there. But really, what we're visually seeing as separate lines, it's just simply another character in the stream as far as the program is concerned inputting this information. So if I want to write a program to read in these 3 things, and note these 3 things are slightly different than what I had in the lab. I think the lab is easier to deal with. Let me go ahead and write that program. Read in some file.txt. Oops, I'm sorry, .cpp. I know it's getting low. Let me pop this up a little bit. Okay, so I'm going to say ifstream my input file. I read that in, or open that for reading as input. And then the first thing I'm going to do is say my input file. Oops, I'm not going to say that. I'm going to say getLine. So getLine reads in a string into a string variable, and I've created one on line 8 called myString. Or actually, let's go with the theme, and we'll call it happyString. This right here is where the input is coming from. It doesn't have to be a file. You can put C in there if you wanted, right? Just anything that takes input. And then here I list my string, so happyString. And then this wasn't in the video. I don't believe this is in the video. There's an optional third character that we can put here. And that third character is the character at which point input should stop. And then that character that you specify is gobbled up. So let me give you an example. How about I put the letter I right here? What that means, looking at this top pane, is that what it's going to do is it's going to put into happyString characters up until it finds an I, and then it's going to gobble up and discard that I. So it'll read in 2 spaces, a hard tab, 2 more spaces, a T, and H. It hits the I, so it gobbles that up and throws it away, and then everything that came previously is what's shoved into happyString. We can go ahead and test that real quick to make sure. What I'm going to do is I'm going to create little arrows here. Makes it a bit easier to see what's in the string. So whatever's between the arrows is what is happyString, and then I'll throw an endline in. All right, let me go ahead and G++ standard equals C++11. Oops. Read. Okay, I've got a bug. Let me zoom this in. Can anyone see the bug? What bug do I have? It would not compile line 7. Why won't it compile line 7? That's right. If you want to work with F streams, file streams, then you need to include the information to let the compiler know what file streams are. So that's that. Let's try compiling again. And victory is ours. All right. So the stuff between the arrows is what is in happyString. And sure enough, a couple spaces, a tab, 2 more spaces, and then T and H. And remember, we read up to the I, so it doesn't include the I, but it does discard the I. We can confirm that. Why don't we add another? Let's put another get line. I'll read it into happyString again. And let's see. Let's stop at, where did it stop last time? It gobbled up this. So the next thing to be read in should be an S, and then a space, and then an I and an S, and so on and so forth. How about if we stop at the letter A this time? And I'll copy this print output line so that we can see it printing out. So we stop at the letter I, then we stop at the letter A. All right, there's that original one. So it stopped, it gobbled that up. The next thing should be an S, and sure enough, we see S space, is space. So there's s space, is space, and then I told it to stop at the a and it gobbled up the a, right? So the next character to be read in is this space here. So that's all kind of preamble to get at what the normal, I guess I used the word charitably, but at least in 111, how we would normally be using getLine, which is, as the name of the function implies, the most popular thing to do with this function is to get a line of text. Now, a line is meaningful to us humans, which basically means everything up to the end of the line, and what it means to the computer is up until you see a new line character. All right? So I can make that specific. What I'm going to do is, for posting this to the daily diatribe, I'll leave all that code in there, but I'm going to comment it out, and let's kind of start anew. So I say get line, my input file, grab that, oops. My input file, happy string, and I want to stop as soon as I hit a new line, and then I print that out. Pilot, all right. And then we see this is a happy phrase, which was that first thing I typed in, and it includes all that leading space right there. And it ends after the period. It gobbles up this new line. So note the next thing to be read in is this second new line right here. Now to make it even more specific, not only is it reading a line the most common thing, but it's so common that if you want, you don't have to specify this third argument at all. And if you do not specify that third argument, it will assume what I had put there. So if I don't put anything there, it'll put a new line there for me. And that's what this version of the function means. Yes? Why did it skip every 2 letters? Oh, the I and the A? So this version of it or the older version I was running? Oh, these? No, these are every grouping here is a single character in the file. Let me come down here. Whoops. All right, so this is some file.txt. Space, space, tab, space, space, the letter T. So that's just saying that's a space character, a tab, 2 space characters, and then the letter T. So this is not a letter S, letter P, a letter S, letter P. That just simply means space. Any other questions? All right. So now, what I have is basically the same thing I had on the previous run, except I got rid of that third argument, so it will assume that it stops until it will. The assumption when you do not put the third argument is that it will stop when it hits a new line. So just a quick sanity check. I'll compile and run that again, and we can see that that output's identical to the version I had above when I specifically had that new line character in there. All right. Bringing this up, after I read in this get line, I am ready, let's see, looking up here, happy phrase, so I've read that one in. The next position is this one right here. In fact, what I'm going to do is I'll put this in a file. Now I can highlight things. All right, so it gobbled that up, and where my cursor is the next character to be read in, that second new line, right? Which would be where my cursor is down here, right there on line 2. What I'm going to read in next, I'm going to zoom in on this for just a minute, is I'm going to create an integer called num. And I'm just going to say not cin. What am I talking? My input file. So this is for, I don't know how you'd formally say it. I'm going to say it as the chevron version of input, where you just name the input file stream, whether it's cin or an if object, if stream object, and then you have chevrons, and then a variable that you're going to shove information into. When you use the chevron version of input, it skips all leading white space until it finds something that is not white space. And once it finds something that is not white space, then it starts using that as input, and then it'll cease once it finds white space again. Now, white space is 3 characters. It's either a space, a tab, or a new line. Those are the 3 things that constitute white space. So looking at up here, whoops, I'm about to read there. When on the bottom left, when I get to line 12, it's going to skip all leading white space. So it skips the new line, skips those 2 spaces, and then it starts reading the 3, the 2, the 4. It hits white space again, and it stops reading right there. So the next thing to be read in is a new line. And let's see, did I save that? Let me try compiling that. Oh, did I ever output it? No, I never did. I'll put it there, and I'm going to steal this output. I'll call this num. And you can see that it indeed did skip all that white space and read in the number. So the problem with that the lab gave you was and again, this is not exactly the same as the lab. So and let me take this out. Let me actually make it closer to what's in the lab. And let me redo my octal dump. All right. So it reads in the 3, the 2, the 4, and it stops right there. The problem with the lab is you read in a string, you read in a number, and then you have to read in a string again, so you rely on getLine once again. So I'm just going to copy and paste those 2 lines. So I use getLine to read in a string, and I'm going to print out that string. And we expect to see I am happy printing out that 3rd time. And that's what you end up getting as output when you do the lab this way, is you don't get anything. So just to emphasize where we are, input first string, input a number, input second string, and the reason is that where that cursor is the next thing to be read into the file, which is the new line character, right? Because when we read in the number, it stops as soon as it encounters white space. So the get line on line 18 here is going to read in characters until it encounters a new line, and then it's going to gobble up that new line and throw it away. Well, looking at this, the very next thing to be read in is a new line. So it reads in that one character and its job is done. It kept reading until it encountered a new line and then it just gobbles it up and throws it away. So after line 18, it ends up right here. And that's why we have down here an empty string. Because there's nothing, it didn't read anything in, it just read in the new line, it says my job is done, it makes sure that happy string is empty. So what you need to do in the lab is you need to basically somehow get past this new line so that your get line on line 18 starts to read where the cursor is at the letter I, right? The first letter of the next sentence. And there's a handy little function called ignore. It's tied to an input stream. Ignore works with cin. Basically anything you can do with the file, you can also do with cin. But what I'll do is I'll say my input file dot ignore. And you put a number in here, which is how many characters you want to ignore. Well, I just want to ignore one character. And in the same way that this get line defaults to an easily remembered value, if I don't put that there, it defaults to being a new line. If I don't put a 1 there, it defaults to being a 1. And now, after I do that, the ignore is going to take us past the new line, and it should make the next thing to be read in the letter I. And so the get line on line 19 starts at the letter I. And there we go. So that was the big poser. And again, the purpose of the lab is to get you to start to realize that the computer is just looking at input, or output for that matter, is just a stream of characters, not discrete lines like in a document how we would see it. New line is no more unusual than the letter X. It's just a character that's being processed. Any questions? Let me look at this. I said that I'd take questions, nothing there. Anyone done with project 2? Oh, a few people. All right, good. Okay, you know who to pick on then. Anything else? I think I'm thinking of cutting you just loose a little early. All right. Go ahead and you have time to get that smoke before lab at the top of the hour, so off you go. See you in lab either later today or tomorrow.